Thanks for taking the time. Customers across the globe, if we think about the telecommunications industry, have been looking at creating differentiated solutions, AI-driven networks. There is a big urge to drive differentiated offerings that they can provide both to the consumer and businesses, and taking a digital-first approach. That's what this talk is about today. Welcome to TLC302. I'm Robin Harwani. I lead the global technology teams focused on our worldwide customers and partners in the telecom IBU at AWS. And with me, I have Lana. Lana?
Hi, I'm Lana Gluck, and I run North America Telecommunications Solutions Architecture for AWS. Thank you guys for coming.
Hello. Awesome, Lana. Just to kind of set the scene, Lana, why don't you tell the team what our customers are telling us globally?
Sure. I'm afraid right now our customers are telling us we are standing between them and the happy hour, and that is not the position I like to be in, but we'll make the most of it. So as you can imagine, we work with many global communication service providers, or CSPs, to help them transition their infrastructure to digital and AI-driven transformation. As we work with them, we see quite a few patterns. Even though the telcos we work with are very different, they're different sizes, they're at the different cloud maturity levels and so forth, there's still certain things that are common across all of them. First, telecommunication companies are creating and accelerating revenue through new revenue streams that are enabled by the new technologies such as 5G and AI/ML. In this industry, telecommunication, like many other customers that we have, try to improve their profitability. And for that, they're looking to shed their capital expenses and their operational expenses. And that they're doing by reducing their hardware on-premises footprint and migrating their applications and network functions to the cloud. By leveraging generative AI technologies such as chatbots and recommendation engines, telcos can provide hyper-personalized services to their customers as well. And they are delivering customized products and services to them. And finally, we see telecoms becoming strategic partners for many different enterprises that are looking to innovate. Telcos are leveraging infrastructure connectivity and their expertise to provide 5G and IoT technologies to companies across the globe. And from this, it is pretty evident that choosing the right partners to do your transformation with and getting the right enablement is key to the business success of our customers.
Thank you, Lana. I think it is critical, as you can all imagine, across these goals. One of the questions we get asked by our customers, how does a CSP plan the journey to be digital telco and have a cloud-native, sustainable, AI-driven 5G network? That's a lot to achieve in 60 minutes. There is a lot of deep dive architectures we are going to get into, so we look forward to that, diving in with you guys. But to level set, what we are going to cover today is 5 domains within the telecommunications networks. The first, how do our customers, telecom customers, create differentiated solutions, both for consumer, business, as well as the B2B2X, the business to business going into consumer or another business solutions. What kind of frameworks do they use? How do they operate across different ISVs, partners, and the other operators that they need to interoperate with from a roaming perspective, from interoperability perspective? Then we'll dive into customer experience. Lana will walk us through that. Going into the customer interaction layer, created differentiated customer experiences, and making sure while they do that, taking a cloud-first, cloud-native approach. Then how do they modernize their OSS and BSS systems to make sure that these systems are ready to offer bespoke as well as repeatable offerings for consumer and businesses. Then we'll dive in to the core, the network core, and the access network. So there is a lot for us to cover. And to kind of set the stage at a very high level, 10,000 feet, if you think about it, setting up an entire network, if you were here a couple years ago, this was our framework. We set we have the regional infrastructure from AWS that can be used for deploying applications across various availability zones in a highly available, resilient, performance optimized, and secure environment. Then we have our local zones and outpost infrastructure that allow for workloads that require high data rates as well as low latency to be placed at the edge of the networks. At the same time, use cases that require applications to be deployed at the edge can be deployed within these local zones and outposts at the edge of these 5G networks. And finally, at the far edge of the network, you have the virtualized access network components. This is deploying at thousands and thousands of radio locations, deploying virtualized infrastructure the same way our customers have been deploying infrastructure in the cloud and at scale deploying applications, the same observability framework they can leverage at the far edge. But since we launched this framework 2 years ago, we have learned a lot. And there are many vectors to think about. Lana, do you want to take the team through that?
Absolutely. Thank you for covering the 100-level view of this. However, we cannot use the same framework for all of our customers across all the operators. We must factor in multiple dimensions when we help our customers define their journey to the CSPs across the world. So some of the things to consider as you are embarking on your journey is, first of all, is your CSV a connectivity focused primarily providing the underlying network infrastructure and basic connectivity, or are you a full stack CSV providing a number of other services and offerings and the whole suite of potentially additional products and services on top of your network? In such case, if you're the latter, then you're going to have to think about your customer experience a lot. Are you a multi-country telecom like Vodafone or Orange, for example, operating across different countries? In such case, you would have to take into account the local regulations and potentially local data sovereignty rules, which is a pretty big consideration as well, especially in Europe. Not every country is going to have an AWS region either. It doesn't mean that country cannot deploy in AWS. It just means they will have to use a different region. In addition to that, not every region is going to have the same suite of services offered in AWS. So all these are things to consider for global companies. Selecting the right partner is another critical thing to think about, critical decision to make. AWS has hundreds, if not thousands, of partners, but you will need to select the partner that makes sense for your business. Maybe you have an existing relationship with an ISV that you want to build on, and that would probably play into your partner selection as well. In addition, telecoms have different cloud maturity levels. Some of our customers are fully enabled in the cloud and understand as much as we do probably about certain aspects of AWS, while others are just beginning on their journey. And where your company is going to play a pivotal role of how you're going to start your transition. In the end of the day, it's going to have to make sense for your business. So where does it make sense to start? What can you do in parallel? And what can bring the most value to your business? So these are all the decisions that you're going to have to think about while making your transformation. And here today, we are going to try and help you frame the way to make these decisions.
Thank you, Lana. So we covered the 10,000 feet. We dive in, understand the vectors like multi-country operators, different journeys within the ISV ecosystems, the organizational readiness. And then once we dive into the first one, how does an operator start and build an entire solution that helps them differentiate across their consumer space, across their SMB domain, as well as the enterprise domain? And why does the operator have the right to play or unique position to capture this opportunity? If you think about it, on this chart, at the bottom of this chart, in each consumer or a commercial customer, there is a connectivity provider. On top of that connectivity layer, which is powered with many, many different types of devices across different protocols, makes, models, you have the entire ecosystem of devices and services, over-the-top services that are powering up value to your consumer as well as the enterprise customers. The common value that each home has or each customer has is the CSP, the connectivity layer, that has visibility from that home router or from the connectivity in the home into the entire set of devices, services that are geared up. And that, we believe, is a very unique opportunity. We've been partnering with customers like TELUS that have helped us to create how we can formulate a framework that can be used across the industry on AWS to create offerings like this. So let's dive into the framework. If you think about this framework, we have worked with TM Forum, the ODA, the Open Digital Architecture Framework team, as well as very closely with our customers and our partners to say, how do we create offerings that provide B2B as well as the B2B2X solutions while reducing the complexity across a fragmented IoT ecosystem, fragmented connectivity, device, and services ecosystem. And so at the bottom, if you can see the connectivity and the network layer, under which there is dozens and dozens of devices, and we will dive deeper into it as we go. On top of that, there's AWS services that allow for our customers, operators, to stitch together various unique CSP services, which is then exposed with a common API exposure layer, very, very similar to what you would think of in the ODA framework. On top of which, customers on the common platform, the CSPs can provide consumer offerings, SMB offerings, and the enterprise user offerings. This is where there is a completely differentiated transformational approach that we believe, instead of having separate monolithic systems that offer bespoke value to the customers, taking a horizontal approach and stitching together in alliance with the standards bodies, and taking the best practices and giving this framework to the industry, top of AWS, will enable a new set of ecosystem innovation. Now, if we take an example of taking the framework and apply that to our home, this is the work that we have been doing with the TELUS team. At the very bottom, just like I said, devices layer, there is cameras, thermostats, there is locks, smart bulbs, lights, controllers, so many different devices that integrate into AWS through the AWS IoT portfolio. Now, you will observe here that the connectivity layer is abstracted out, but you can very well assume it's either a fixed or mobility network that is powering up the connectivity here. From that point, there is different services that can be used, such as API Gateway, Lambda, clean rooms for data management, the telco lakes services that we can pull together from a lake formation perspective to create services that are then offered by the operator to achieve value. So what could be those services? Things like providing home security, convenience, SKUs, things for energy management, along with the unique things that operators network enables them, the identity, the omnichannel experience, the care, field services that they can offer, experience optimization, notification management, all of these capabilities with a single bill and care framework that can be offered to customers. And that's what we believe is the digital life solution that can power up not just the consumer experiences, but also the business experiences. Now, there is multiple layers I covered. You can see the first and the second layer. If you map it to the framework we saw on the earlier slide, are the devices, the first and third party devices. Then you have the AWS Cloud, the CSP middleware, and then the smart apps that you have. But so far, we haven't covered what new launches we have done. How does that change the platform? Now, here, generative AI enables to offer additional value, completely transformative experiences, and different different new offerings in this space. For example, if you are going into the home, looking at device data across your health devices, whether it is Fitbit or Apple devices, different devices, you can, as an operator, provide value to consumers for elderly care, anxiety, real-time translation, anxiety detection, and taking actions. There is a lot of routines that can be offered and be proactively recommended to the consumer based on the generative AI capabilities that we can think about. So how does the reference architecture look like if we go even deeper? So from right to left on your chart, you can see you have third-party clouds, different cloud providers that enable for these devices in your home to operate. Then you have your consumer premises, where you have a bunch of gateways, IoT hubs, Echo devices, hopefully, a lot of different user devices that are there as well, working in conjunction with the existing telecom network, which is a fixed network or a fixed and mobile network. These days, a lot of FWA offerings as well. So that integrates into the AWS Cloud, then integrates into the zero-touch solution that we have built along with the experience controllers, integrating into the AWS IoT framework. All of the data, both across the telecom data as well as health data, can be persisted and managed across the lake formation services. And then you have the application middle layer. The application middleware is what the operator either licenses from a partner or builds itself to create differentiated offerings like identity, notification, orchestration, like we discussed about in the previous chart. And then that is augmented by the generative AI capability. So if you think about it, generative AI with the previous framework enables these services to be then offered through the common marketplace that the telecom consumers are looking to avail with a single bill and a care framework. If I take this to the next chart, these services then can be offered both to consumers as well as enterprises. Now, the last bit that we talked about in the framework was the marketplace, a frictionless experience for customers to bundle together offerings from multiple operators, multiple ISV partners, as well as end users. And that's the marketplace solution that can integrate into AWS Marketplace through Service Catalog as well. We are doing this with multiple operators, OneTel being one of them, TELUS, NTT, A1, just few examples where we have this platform live. So how do we do the same thing if the customer is an enterprise, the same marketplace, the same framework? How do we extend that all the way from offer, orders, usage, and service? So here, this is another example where we are doing this with an operator in North America, where we're working with Salesforce, Nokia for charging, our own Wavelength service team, as well as Amazon.com integration for retail hardware bundles that can be packaged into the offer that goes out to the customer. All of this to create a new 5G MEC experience with our ISV Partner Summit to give a seamless VR experience to the customers. So that hopefully provides you a little bit of context of how an operator can leverage a framework, create offerings, a platform which can be used by different lines of business to offer services and differentiate, including how generative AI plays a role there. So Lana, do you want to take the team through the next bit in terms of customer experience?
Absolutely. Customer experience is one of the top factors impacting customer loyalty. This is what 95% of our customers tell us. With COVID-19 pandemic, our expectations as customers of seamless digital customer experience have definitely heightened. And we are very quick to move on when we don't get the digital experience that we want right away. To keep pace with customer demands, many companies are leveraging new technologies such as 5G, IoT, Gen AI, and AI/ML to deliver excellent customer experience. These enterprises are relying on telecommunication providers for the network speed and for the infrastructure that is required, as well as the bandwidth that is required to support these new use cases. However, when we think about telecom, this probably is not the first thing we think about when we think stellar customer experience. Telecoms, in many cases, struggle to provide that to their subscribers. So why is it a challenge? So I will ask you a little trivia question. Who knows when the telephone was invented? A year. You can yell out any number. Who thinks that it was before 1900? Good. It was before 1900. It was actually 1876 when the first telephone was invented. And believe it or not, the first telco was established even before then. And this telco still exists today. So BT was one of the first ones. What I'm trying to say is that telecommunication companies are very old legacy companies. A lot of them are large. They've been around for decades, maybe even over 100 years for some of them. And they have accumulated a lot of legacy technology over time. And you can imagine that, and you probably know from experience that innovating in such an environment is not easy. Rip and replace methods don't really work very well if you think about the complexity of the systems that telco has to support. So CSVs need a more effective ways to leverage customer journey data that they have to guide their customer experience decisions and transformations without having to undertake and complete large-scale technology overhauls first. So what I would like to share with you today is a solution that I was lucky enough to be a part of. This solution can help telecom operators improve their customer experience without ripping and replacing their legacy systems first. The solution is called Connected Customer Journey, or CCJ, and it utilizes a federated data lake approach on AWS to bridge organizational and data silos in telecoms. It connects to telecom's existing data storages and systems, providing real-time visibility into customer journeys across channels of interactions. Additionally, the data is also aggregated for further analysis and making further business decisions. CCJ platform applies across the customer lifecycle, providing a comprehensive view into the customer journeys over time. So the customer journey is not something that happens, within a few minutes. It could be something that takes days or even weeks. For example, if you try to buy a new phone, it's an expensive purchase. It may take us longer to decide. And through that time, we are going to do certain things that we can all accumulate and connect. Anyway, the key benefit of this solution is enhancing customer experience without having to replace the legacy systems that we have in place. And I want to look a little bit at the systems and services that we are using for that solution, for that platform. So we are going to start with the data source layer, where all of the telecommunication data sources exist today. And this could be on premises, it could be on the device, OSS, BSS systems, and maybe call center logs, and so forth. All these stay in place and don't need to be replaced. The second layer is the data ingestion layer. And this is where the data from these data sources is going to get consumed and ingested into AWS Cloud. So for that, we can use several different methods, and some of them are listed here. We can use Kinesis and Kafka. We can use batch loading with Glue and AWS Transfer Family, if this is what suits our use case. Or we can use APIs through API Gateway. In this case, all these systems can actually call APIs with the events that we are interested in, that user is going through, and ingest them into CCJ. So once the data is in the CCJ, what do we do with it? we build something that is called connected journey graph using Amazon Neptune database. It is a scalable database with high availability. It is also serverless, and it is a graph DB. What it does is to accumulate all of the steps in a customer journey and connect all of them into one journey. Some of the data, the raw data, we store it in Amazon S3 buckets as well for analytics, and we use lake formation for easy access control. We also leverage AWS Glue to move the data into the graph database and into our next layer. And our next layer is going to be the connected customer journey insights. So the system has two layers. The first layer we talked about was core, and this layer is the insights. And this is where all the magic happens. This is where data is analyzed, and we generate valuable customer insights that can be used later. And these insights can power real-time data that's sent for customer agents, for example, that are talking to the customers. It could power business dashboards where it can help us make better business decisions. It can power hyper-personalized chatbots to have interactions with the customer that are within the context of their transaction. So with that, I wanted to dive in a little bit deeper into the architecture for CCJ Core. All right. Let it build out. So CCJ Core is responsible, as I mentioned before, for ingesting data from your existing systems into AWS. In this case, we are using a stream like Kinesis, for example, to ingest that data. So your data sources essentially publish events onto the stream in a standard format. These events are published, and as they are published, the metadata is also extracted real-time by the event processor. You can see it here in orange. Additional metadata can also be extracted by the metadata extractor once the events are in the database. So you can see that on the bottom at number 4. This metadata is stored in the Neptune knowledge graph. And the knowledge graph trains customer journey models using SageMaker. These models can predict things like purchase propensity of a customer or churn propensity of a customer. So basically, this is where we gain the insights. And then the telco insights. So what happens here is first, we extract customer segment data, and the segment could be prepaid customers or postpaid customers, or maybe customers in some geographic area. We get this data, and we save it into the S3 bucket. After that, we leverage AWS Glue jobs, getting the data out of the S3 and putting it into Amazon Redshift warehouse. Additionally, we will leverage customer journey analytics APIs to retrieve metadata and insights regarding customer journey events. And finally, we build the custom applications and visualization using this data inside. We can either connect directly to the Redshift to build these applications, or we can funnel the data into the external systems like CRM systems, for example. And this will provide customized reporting and analytics on the customer. I am not going to dive into this architecture just because I think I'm jamming you on time as is. But basically, what this shows is how we can use CCJ, in this case, to send a hyper-personalized offering to a customer who, with the latest event, connected customer journey, decided that the churn potential of this customer just went up. So if you want to know more about the architecture and see the actual demo, you should definitely stop by our demo booth in the Venetian. It's booth 580. AWS for Industries is the area where we have a booth there. So very quickly here, basically on the right, you can see the dashboard. It's just an example of a dashboard that we can generate using these analytics. Here you can see the ARPU of a user, the CSAT by product type, average number of channels switches per day by intent. These are just examples. A lot more is possible with this system. But let me ask you this. How are these customer journeys enabled? What are the backbone systems that are running behind the scenes and enabling customers go through their journeys? Anybody wants to guess? Because these are the systems we are going to talk about next. You can yell out.
OSS, BSS.
Yes, but you knew that. Okay. So we'll talk about OSS, BSS systems. I want to give a very quick refresher in case you don't know. So OSS systems helps manage the complex technical network infrastructure and hardware and switches and software that services all that in data centers. And some of the key OSS functions include network inventory management, fault and performance monitoring, traffic engineering, and so forth. So when you think OSS, think network and network services, network servicing software. Now, BSS enables the business processes that support customer acquisition and service delivery, and care. BSS functions like product management, order, orchestration, customer billing and invoicing, and CRM help drive the optimal customer experience. So when you think about BSS systems, you can think about systems that help us interface with our customer. Today, there is one major development that is having a huge impact for telcos, and it makes telcos' reliance on OSS and BSS systems higher. I'm going to ask one more question. What is this development? Don't say. What do you think this development is? I'll give you a hint. It's on the slide in big font.
With a G.
With a G. Yes, right. Thank you. So 5G networks are about 100 times faster and about 1,000 times greater bandwidth than 4G, providing telcos tremendous opportunities with new business revenue streams. With 5G, telcos have a power to capture more customers and to drive growth. So why is there the increased reliance on OSS and BSS systems with the arrival of 5G? Well, for one, 5G is using a new radio frequency. It's using dense small cell architectures and virtualized technologies, which make OSS support for them a lot more complicated, and it requires upgrading the OSS systems. In addition, with the higher speeds, there is a lot more data that is now going through the network. So for that, we also need a better OSS and better BSS systems. It also opens up a whole array of new value-driven businesses. The network slicing, for example, now enables us to charge our customers based on usage, not based monthly subscription, for example. So all of that requires us to upgrade our OSS and BSS systems. And this is a pretty urgent need for telecommunication companies that are looking to innovate. If your telecom organization is running legacy OSS and BSS, you will not be able to take full advantage of 5G. So it is critical to embrace new OSS, BSS models, as well as migrate to the cloud. So how will modernization of OSS, BSS systems and 5G and network slicing capabilities, together with AWS services and SaaS delivery models, enable telecoms to better modernize their 5G architecture? Well, by choosing the right partners, and we talked a little bit about this earlier, and we have some industry leaders like Ericsson, Nokia, Salesforce, Amdocs. AWS is enabling telecom operators to adopt a SaaS BSS model. And together, we are creating bundled offerings based on usage rather than standard offerings that are the same for all kinds of consumers. So if you think about a large company who is a consumer versus a small company who is a consumer, they're going to have different SLAs, they're going to have different bandwidths that they require, they're going to have different amounts of data that is needed to power them. So that's why we need to create these bundles that are now centered around the usage, the amount of usage in SLAs. So AWS provides the agile API-driven architecture required to support dynamic slicing and on-demand slicing provisioning.
Just to add there,
please.
Great point. Like since we started our OSS BSS partner ecosystem and our community of partners that we have been working with since 2018, we've worked closely with our standards and framework bodies like TM Forum to make sure that our best practices from AWS are then transposed into the leading edge Catalyst, leading edge ISV partners, and vice versa. We've adopted a lot of learnings from the industry bodies to make sure our ISV partners are truly building cloud native OSS and BSS systems. Now, as we go into the architecture, you will hopefully see how the entire frameworks that we have translate into a tangible architecture that you can drive to production across all the layers. Go for it. I just wanted to add that.
No, thank you. I appreciate it. So if you look at the architecture, we are going to start at the data center. So on the left, you would see technology that you would have on premises. You may have your Active Directory or your DNS, your databases, and servers. You would connect to AWS, whether you have a direct connect, you can use that. Otherwise, you can use client VPN. And the next layer that you see here are all the AWS managed services that you may use. This is going to be your landing zone, and you will see 2 availability zones for high availability of your applications. You will also see the VPC and the connecting layer into that. Here is where we are going to build your applications. On the bottom, you're going to see the data layer, and it's going to use cross-AZ replication, again, for high availability of your applications. Your compute is going to be in this layer, so whether you're using containers or not, you would want to use auto-scaling here, and all your compute nodes are going to be here. Your file storage and your EBS storage is going to be in this layer as well. And then you have basically your public subnet with the integration layer where you're exposing your APIs, or the other way around, if you're consuming APIs from external API sources, is going to be here as well. So this is a pretty typical reference architecture for OSS BSS, and there are a few things that you would want to think about. One, like with any AWS deployment or any public cloud deployment for that matter, you want to make sure that you put your, and you think about the cost and cost optimization, optimizing your architectures before you do anything, because we don't want to overpay. So this is where we want to have our auto-scaling groups. We want to use serverless as much as possible, and so forth. One other thing to consider is that a lot of OSS BSS applications are highly latency sensitive. Highly latency sensitive, and it is very important for some of them to be close to our customer. So this is where AWS can augment your on-premises with the cloud continuum, whether it's going to be our regions and availability zones, or maybe the edge, which will bring your data and applications closer to the customer. So with this ubiquitous cloud continuum enabled by 5G edge computing, BSS functions can be deployed in a flexible, distributed architecture to optimize performance and latency and costs. I'm going to go through this quickly because I think we are up on time. But basically, if you look at this slide, on the left, you're going to see all the different telecommunication companies that we work with. And here you will see some of them that are tier 1 telcos in the US, like T-Mobile, for example, or Vodafone in Europe. Or you're going to see Liberty Global, this one, Liberty Latin America, actually, excuse me, that operates across 5 different countries in Latin America. There is Globe, and there is Altice. Some of these operators don't even have a region in the country they operate, and yet they're able to deliver services to their customers using AWS. Globe, for example, is servicing Philippines and is utilizing the Singapore region to deliver their first APG network assurance platform deployed in AWS. So basically, there is a huge diversity in our customers. If you look at the second column where you'll see the partners that they're working with. You'll see some like Amdocs and Ericsson, Salesforce, and for some it makes sense to go with others. So anyway, in AWS we have a lot of different partners where there's quite a few choices based on what your business needs are. I will go quickly through Liberty Latin America use case. Liberty Latin America is a leading mobile broadband provider in the Caribbean and LATAM, and they have become this leading global provider by going through a number of acquisitions. They had at least 4 major acquisitions, including Claro Chiles, Claro Panama. They acquired AT&T operations in Puerto Rico, and they acquired Telefonica in Costa Rica. So if you think about that for a second, and think about the variety of OSS and BSS systems that they needed to integrate into one, it was a pretty huge undertaking. They decided to go with the architecture that leverages outposts, local zones, and US one region. If you look at the circle here, you will see all the partners that they're partnering with for different solutions. They decided to go with cloud-first platform with OpenAIs on AWS, which is a departure from traditional BSS delivery models. Migration to cloud agile methodologies fundamentally transforms the way IT can work with business and come up with the new business products for their customers. So eventually, when they are done, the BSS system in AWS is going to support all of these acquisitions as one. Another example is T-Mobile that was able to implement blue-green deployment for their vast footprint in the cloud that includes over 5,000 compute nodes. I'm going to move on here just because I think we have a lot more to cover. But basically, to sum it all up, there is a customer journey. And if you think about a customer buying a phone, what do we do? Well, we do research. We then engage with our provider. We purchase, we activate the phone, and so forth. Each one of these will have a flip side of operator journey. So while we research, operator needs to plan and forecast how many phones, for example, they're going to sell. While we get our phone and turn it on, operator needs to make sure that they provision and activate it. So it's kind of like the 2 sides of the same coin. And here in orange are all the use cases that we have implemented using generative AI technologies. So we have upgraded the way that store assistants work, for example, or the revenue assurance is one of the other prototypes that we've done with Orange that has worked really well for them. So just now I would like to ask Robin to take us to the core element that is underpinning all of that.
Thanks, Lana. Yeah. So hopefully as we started at 10,000 feet. We talked about how do we place different workloads. We had that 10,000 feet slide where you could just take a network, you take an entire telecom operator's workloads and place them in different places on AWS infrastructure based on data networks and latency profiles. But as you saw, we walked through consumer and business offerings that can be built with marketplaces that are TM Forum ODA compliant. On top of that, then we went into the customer journey. Then we went into the OSS BSS framework that we have to cover. And now we will cover the networks, right? As CSPs build out their networks, they have few critical requirements. This is something that has been going on for some time. They want to make sure they're building a secure virtualization environment which is private, managed by them on AWS. They want to make sure there is cloudification at the edge for applications to be deployed at the edge for data throughput as well as low latency requirements, ability to segment and deploy updates, upgrades, and new capacity of the network is critical for operators. And while doing that on the same infrastructure delivery CI/CD pipeline, it is critical. Our customers like Dish want to deploy software updates on their radios across thousands and thousands of locations. And then they want to monetize this network both at the central points of presences as well as at the edge by deploying applications. Now they want the largest community of partners that can build and deploy these applications at the edge as well. So our approach with them is to extend our ubiquitous cloud to the edge for the telecom workloads, extending cloud to telco edge locations within operator premises like what we have with Outpost services. And for joint go-to-market, we have Wavelength that enables them to do the same thing for enterprise applications to be deployed as well. Now, if we think about how do we jump into an architecture, how do I build out a 5G core network quickly leveraging AWS? Now, here's the architecture. If you look at the far right of your slide, you have a region where you deploy your control plane, leverage the management tools that you have available, the same CloudWatch, the same CloudTrail, the simple systems manager to update, and manage the network. You're using EKS, Kubernetes clusters to deploy the control plane. You're extending that to the edge here in this scenario with a local zone. And in that local zone, you're deploying the user plane in a CUPS architecture. And there, that is then integrated into a telco data center, hopefully at a site, where you can use both AWS Outpost or 1U, 2U Outpost for virtualizing your radio location, and CUDU, for those of you who are familiar with that. I'll walk through the access network in a bit as well. The important thing to understand here is the breakout. The local breakout is happening in the local zone, and you are going through the IGW or an LGW here to traverse the traffic to the internet. To deploy this same core platform, you can do that in a primary and secondary scenario, an active scenario, capacity expansion scenario, or a disaster recovery scenario. You can do the same thing in a second configuration here using Outposts. And here the difference is the Outpost, a full rack Outpost, can be deployed in the customer's premises to deploy the user plane of the core network. See, the value here is the same observability that you have across the deployment, the same CI/CD. We have thought through things like DPDK, Multus that are required for network segregation within the VPC, which is extended both in the region as well as to the edge, which is available. Now, a live customer, for those of you who are aware, Dish has been our customer for the last 2 years, 15 plus local zones, 16 availability zones across US, like we spoke about. Thousands of site-specific hardware connected to AWS Cloud. We have the same command and control fabric. If we go deeper into this architecture, like I spoke earlier, there are national data centers where the OSS, BSS, the subscriber management, the front-end systems, the IMS core control plane is deployed. Then there's the regional data centers, the local zones where the user plane is deployed. And then there is the edge data centers where the UPFs, the user plane of the 5G core, as well as the centralized and the distributed unit of the radios are deployed. So far, we covered the consumer business solutions, the customer journeys, the OSS BSS platforms, and the core and IMS systems that you deploy. Along the way, we understood generative AI capabilities that would be deployed. But there's one thing that you may ask about: sustainability. That was the title that you read when you walked into this session. Sustainability with Graviton 3. With Graviton, what we have been able to do is, now today, this morning, Graviton 4 has been announced, so I have to be careful in terms of which version of Graviton chips that I talk about. But Graviton 2, we have been able to achieve, working with NTT Docomo, a improvement of 72% in terms of power efficiency. You can look out, and I have limited time, so I will jump in off it, but 72% power efficiency we have been able to, energy efficiency we have been able to achieve. And in this space, we have been working on generative AI as well. There are 3 critical categories that we are working on: closed loop orchestration, the ability to have analytics, and the ability to reduce the amount of manual intervention when adding capacity to the network is critical. Closed loop orchestration, the easier operations when it comes to root cause analysis management, as well as providing in-depth analysis and breakdown of KPIs, and then user experience enhancement. What does that mean? That is going into the OSS framework that Lana talked about, and the ability to provide the user experience, troubleshooting, and user call simulations on the same platform. All of this, if you're running a network that is in an on-prem environment, not integrated into analytics and the generative AI capabilities, would not be easy to achieve. And these are things that we believe are critical for our customers as they evolve the 5G networks for both efficiency as well as monetization. The final piece is access networks. And within access networks, you understand, those of you who are in the telecom domain understand, it's a highly competitive, very distributed space. And it is very, very critical for customers to have a solution that scales across 10,000 plus locations. And this is a space where it is critical to understand how the architecture works. So for those of you who are not close to this, the RAN has the RU, the radio units, which are then integrated into the distributed unit at the cell tower, integrating into the central unit, a near real-time RIC, which allows for radio information controllers to be handled. And then there is a non-real-time RIC, which is your management function of the radio. So when you translate that, how do I leverage AWS for these functions? For the distributed unit that connects to the RU, the radio unit, you can use Outpost and EKS Anywhere as well, if it's existing infrastructure that you're leveraging for deploying the radio sites. You have local zones where you can deploy your CU. You can also deploy your CU on the Outpost based on the transport capacity that you have available. So how would that translate into an architecture? We saw this before, and I said I will come back to this. It is critical now to dive into the left side for you of this architecture. We have the COTS infrastructure, if you see, where somebody can deploy EKS Anywhere, deploy virtualized DU on top of it, a virtualized CU as well. And you also have Outpost servers, which gives you full control extensibility from the AWS region, just the cloud at the RAN, where you can deploy across thousands and thousands of locations. Now, if you think about how would you go and deploy one of these for ORAN deployment, this is the framework. The same centralized observability, the same centralized analytics, all of the pieces that you need, starting from left to right. If you see in the region, you are seeing the non-real-time components, the management components that you need to deploy. Then you have the regional sites where there is workload can be deployed across the CU, the centralized units of the radios can be deployed on the Kubernetes environment. Here, you also have the same benefits that I talked about, the same CI/CD pipeline, the segmentation of network, the ability to deploy across parts of the network, have different levels of observability and SMO capabilities, and then have the distributed unit on the EKS Anywhere environment on a COTS hardware or Outpost servers. So to sum it up, if you take the benefit of the virtualization capabilities available on AWS, we have worked on this for the last 5 years. A lot of things have moved in this space. The ability for our customers to differentiate with a network that is truly software defined. We have done studies with our customers is to achieve significant TCO benefits as well as OpEx reduction, 50+% we believe in terms of TCO benefits. And we have, as a matter of fact, deployed CU, DU sites very, very quickly on EKS Anywhere. These are available for you if you walk up to the Venetian Expo. You can see this entire network, not just the core, but the radio access virtualization available for you. And we can walk you through how we have containerized and deployed this with our ISV partners across multiple ISV partners as well. So to kind of sum it up, we went from that 10,000 feet architecture slide. We walked into building consumer business solutions, customer journeys, OSS, BSS systems, core and IMS, and radios, all leveraging digital-first architectures, cloud-native designs, and we made sure we walked you through generative AI capabilities that we are using and how we have architected so far this platform. We went also into how we can differentiate the operator because of having a common CSP point that has many, many devices and services layer when we started. And we talked about sustainability that we can bring to these customers because we have achieved 70+% energy efficiency with Graviton 2. Finally, Open RAN and cloud-native architectures for networks are now ready for prime time in production. We have customers like Paradise Wireless and other operators. We are working in APJ to deploy these around hundreds and hundreds of locations, and as they scale it up to thousands of locations as O-RAN becomes widely available. So that's what we wanted to walk you through in the last minute. There are 2 requests. Please do walk up to the team. They've put in a lot of effort to set up these live demonstrations that are in production at our customers globally. It is at Venetian Expo, booth 580. And to bring this again back to you next year, please do take the time to fill in the survey and hope you enjoyed. Thank you for taking the time. Really appreciate it.